This week on the show, we're chasing a bad commit. We tell you the new FreeBSD Core Team and getting started with NetBSD on the Pinebook Pro, as well as a little tutorial on the Intel 10th generation i3 NUC, PF table size check and changes with going along with that on Dragonfly BSD and more. This week's episode of BSD Now. BSD Now, episode 360, Full Circle, recorded for the 22nd of July 2020. This episode of BSD Now is brought to you by Tarsnap. Go to tarsnap.com to get your online backup for the truly paranoid. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Welcome to this week's episode. We have great headlines and show prepared for you today, so we should jump right into it. Chasing a bad commit is the first item that we have.
Yeah, so this is somebody's blog post, and it says, while working on a big project where multiple teams merge their feature branches frequently into a release Git branch, developers often run into situations where they find that some of their work has been removed, modified, or somehow impacted by someone else's work accidentally. It can happen in smaller teams as well. Two features could have been working perfectly fine until they got merged together, and the result was brokenness. That's a highly possible case. There are many other cases that could cause hard to understand or subtle bugs that even continuous integration systems running the test suite on your project might not catch. We're not going to discuss how such subtle bugs can get into your release branch because that's, there's myriad different ways.
Mm-hmm.
But some of the examples is a commit that introduces a bug or a regression, a commit that changed the code style, a commit caused benchmark performance to go faster or slower, or a commit fixed a bug or whatever. So then it starts digging into how to actually chase it down. So he's got a little comic here showing that on the Big Corp Slack, we see, let's go for team lunch today. It's been a long time. But then the CI bot is like, the build is broken. Oh no. Yes. Because we are the team responsible for shipping the feature, we need to fix those failing tests in the release branch. But everyone on our team is pretty sure that's not our fault because the overall feature was working until some other stuff was merged. But we tried to triage and fix it. So we start with the head commit of the latest release branch. We confirm that the feature breaks on it by running our test suite. Then we checked out each of the previous commits in the Git history until we found a commit where our patch passes. In a worst case scenario, this successful commit could be one that was tagged as a specific version, meaning we have to check out about 100 commits one by one to find a good commit. The commit made just after the good commit in the history would be what we would refer to as the bad commit. If we take such a route, we would end up spending unimaginable hours, maybe even days chasing down the bad commit, and that's not an ideal solution. So option one, we can divide the commits between well-known good commits and a bad commit among the team members and manually check out to each commit according to, and spread out the work. This exercise suits the popular saying, many hands make light work when working as a team. Option 2, the nerd John on our team has a clever idea to implement a fancy tool that would utilize a binary search algorithm that automatically keeps dividing the commits equally by running the test suite until it finds the commit where the first bad commit in the commit history. Or there's an already made version of that called git bisect, which comes built in with Git. And basically, yeah, if you have this range of commits between the known good commit and the commit that doesn't work, it'll start in the middle and figure out which half the breakage started in, and then it'll just keep having it until it finds the broken one. It basically just needs to know for each branch whether it was good or bad. And so if you have a test script you can say, check out this branch, run the test. If it says it's good, then we know it's not this half. The problem must be in the other half. And if it's bad, all right, we know the bad is in this half. And then you just keep splitting the list in half until you find the one that caused the problem. And so they have a little diagram showing, git bisect doing that and cutting the list in half. So you can do this interactively by just doing git bisect start and doing the work, but you can also configure it to use a script to do the work for you. And then you just have to keep marking, you or your script keeps marking the steps, or each chunk is either good or bad until you find the one that actually caused the problem. So yeah, you can do git bisect run and give it a script to run, and it will keep running that script and using the exit status to decide which is good and which is bad until it ends up figuring out what the problem is.
Yeah, very nice solution.
Git bisect also supports marking not just necessarily good and bad. If, for example, it's a benchmark, you can mark them as slow or fast, and you can use it to figure out which one is causing things to be slower and so on. So you can easily change the term that's used for the different results of your script.
That's a good step.
In order to be able to do, for example, both good and bad for tests and fast and slow for benchmarks or whatever inside the same set.
Yeah, people should know about this and hopefully have a script ready that does all the checking and the benchmark.
Because it was actually, I think, a week and a bit ago, there was a conversation on IRC about this in particular. I think it was Top was having a problem where sometimes I think it was the recently added support for when you do top with the -a flag and it prints out the name of the program and its arguments. If you had any special characters in there, especially, Japanese or Russian text, it wasn't well supported. Somebody made a patch that makes it work better, but this caused people without that text to sometimes have corruption because the number of bytes was being miscalculated somehow, and it was causing the text to shift around. And then because of the way top works, it overwrites text in place. And so if it's off in its calculation, then you're overwriting in the wrong place and your screen becomes unreadable. And you could, load the help and close it to refresh the screen, but that isn't, you'd rather top just worked. And so somebody was manually doing this bisect process of just check out a revision halfway through the possible range and keep cutting down the range of which ones were causing the problem. Because, especially in this case, I think it did end up being a commit to top that broke it, but it's entirely possible that the commit that caused the bug wasn't to the program that was exhibiting the bug.
Sure, yeah, that's a good...
in which case, you could try every one of the commits to top and never figure out which one caused the problem. And because it was kind of a run top for 20 minutes and then notice it's corrupted. It wasn't really something you could script to look for a certain string in the output or something. So you couldn't quite automate it. But.
That might take a while. Yeah, in general, if there's text on the screen, it's needs different ways of parsing that. Okay, that is that story. And the next one is that the new FreeBSD Core Team has been elected. So that happened a while ago, a couple weeks. And here's the announcement. Dear FreeBSD community, the FreeBSD project is pleased to announce the completion of the 2020 Core Team election. Active committers of the project have elected your 11th FreeBSD Core Team. So for the people who don't know what the Core Team is, it's basically kind of the board of directors, the governing board of the FreeBSD project. And it's 9 people that put in their names that they want to represent the community and work with the community in the next 2 years. That's the term. And then the committers vote for a certain period. They can cast up to 9 votes. And the people who get most of the 9 votes, they are the new core team. And so the people who have been elected are Baptiste Rossin, Ed Mast, George Neville Neal, Hiroki Sato, Carl Evans, Mark Johnston, Scott Long, Sean Chittenden, and Warner Losh, with some of them being incumbent members, so from the previous core team or previous core teams from like a couple years ago, and also new people who haven't been on core, so that's a good mixture of fresh and experienced, I would say. Let's extend. The message continues. Our gratitude to the outgoing core team members for their service over the past 2 years. In some cases, many more. Yep, people get re-elected. So that's Alan and myself. Yes, we stepped down so that new people can do a bit of work, and maybe we can come back.
Yeah. We've both done 4 years. We deserve some time off.
Yeah. And it doesn't say that we won't run again. It's just a bit of, time off and let other people do a bit of work in the meantime, and we'll watch them closely. Other people who stepped down from the previous core 10, Brooks Davis, Jeff Robertson, John Baldwin, and Chris Moore. As well as, last but not least, to mention Joseph Mingrone, who was the core secretary for this term. 2 years, very nice working with him. And the new core team also elected a new core secretary for themselves. Let me say, Muhammad something, Moinur Rahman something. If I butcher that, I'm sorry. You know who you are. And good luck to the new core team members. And hopefully the community will benefit from their experience and from their guidance or their stewardship, let's say, over the project, and work with them to make the FreeBSD project prosper and shine. All right, time for the news roundup this week. We have an article about getting started with NetBSD on the Pinebook Pro.
So if you buy a Pinebook Pro now, it comes with Manjaro Linux on its internal eMMC storage, but you probably want to install a BSD instead. So let's start with a NetBSD install. The easy way to get started is to buy a decent microSD card. What sort of markings it should have is a science of its own, by the way. I don't know if you've ever looked into what all the different markings on an SSD card mean, but anyway, you can, that's an exercise for the reader. But install NetBSD on that, and then on a warm boot, when booting a running system, the microSD card has priority compared to the eMMC, so the system will boot from there. As for which version to run, there's a bit of a conundrum. There are binary packages, but only for NetBSD 9, whereas NetBSD Current, you have to compile everything yourself, which takes a long time, but the hardware support is better on NetBSD Current. But the solution is to run a NetBSD 9 userland with a NetBSD Current kernel.
Ooh.
As the Pinebook Pro is fully 64-bit capable machine, we're going to run the EVB ARM AArch64 NetBSD port on it. So you can head over to armbsd.org/arm, thanks to Jared McNeil, to grab your NetBSD 9 images for your Pinebook Pro. Then, assuming you're running Linux, you can use zcat to ungzip it and DD it to the MMC. Be sure to check that the device you're writing to with DD is the one you mean to, otherwise you will not have a fun day.
Check twice.
If you would like to replace the pre-installed Manjaro Linux on the eMMC, it makes sense to have your main OS on the built-in storage, since it is quite a bit faster than your typical SD card. In my tests, I got write speeds of about 70 megabytes a second on the eMMC. If you want even more or faster storage, the Pine64 will sell you an adapter board for adding an NVMe drive to the Pinebook Pro. Once you get booted into NetBSD from the memory card, mount the Linux volume and copy over the image file that you made before, then unmount and extract over the exact same way as above. The only difference is that the target device is RLD0D, shut down the system and remove the memory card, switch back and watch it boot NetBSD. And then, like they said, to get better driver support, I recommend using the NetBSD current kernel. To do that, you need to replace the /NetBSD file with a new kernel. You don't have to change the bootloader or anything. So you can grab a pre-built head snapshot of the binary kernel and just drop that file in place. Probably want to back up the old one in case you want to switch back, and then you're good to go.
Yeah, seems straightforward.
You will find that there is now a driver for the built-in Broadcom Wi-Fi, which will show up as BWFM0, but the firmware is missing. To fix this, you need to download the firmware, and those are also on the NetBSD Daily Snapshot website. So grab that and extract it to the right place, and now you will have working Wi-Fi.
That helps. Oh yeah, so check out the article. It's fairly straightforward, and another thing running NetBSD, of course.
Well, one more note on that one. Looks like FreeBSD developer Alexander Timonenko, or whatever, Gonzo has borrowed some of the NetBSD code for the audio drivers and has audio working on the Rock Pro 64 and Pinebook on FreeBSD.
Ah, so you can also play music and other stuff.
Yeah, it turns out to be kind of important for your laptop to have some kind of audio.
Mm. People will miss that, yeah. Okay, yeah, so thanks Gonzo for that work, and also the people who did the original work on NetBSD for the Pinebook Pro port of NetBSD of sorts. It's always interesting to see what devices can run NetBSD. Okay, so now we go into the FreeBSD on Intel 10th generation i3 NUC article by THJ, of course, we covered him on the show a couple times, so he keeps blogging, which is good for us and for him as well, because
if you're interested, there's a blog post about blogging on his blog.
it's kind of a meta thing. Okay, yeah, definitely be encouraged to do blog yourself, and yeah, definitely read the blog of other people. So this one, 10th generation Gen i3 NUC, interesting little box we have from Intel. And the article goes, I have ended up with some 10th generation i3 NUCs to put to work in my test bed. So it's the NUC 10 i3 FNH to be exact. These are quite new devices. The build date on the box is 13th of April 2020. Before I figured out that the true role is one of them might have to run Linux, I need to install FreeBSD current and see how performance and hardware support is. They have an Intel i3 10110U with 2 cores and 4 threads at 2-ish gigahertz with 4 gigahertz boost. Got a single 32 gig DIMM of RAM into it and 480 gigs Western Digital M2 SSD. This configuration came in just under £500 for each NUC. Okay, not so bad. The NUCs are pretty small. They have pretty beefy fans taking up about a centimeter off the top of the enclosure. They certainly aren't silent. Without any load, I could hear the NUC sat at the desk next to me. Especially in the summertime, I guess that's very annoying. When building at full steam, the fan in the NUC is about as loud as my X270 ThinkPad when it is building. Yeah, well, then it's under full steam, of course. Okay, so what works? Out of the box, I had to break into the BIOS and disable Secure Boot to boot the FreeBSD installer. Did this by hitting every function key as the NUC booted. I think function 2 was the correct choice. At the time, my keyboard was being fought over by USB and Bluetooth on my MacBook Pro. Ah, yes, classic problem. But that's easy to fix. FreeBSD install was problem-free. I set up the M.2 as a single drive with ZFS, datasets, and snapshots are a magic power. Before I tried anything else, I had to get an idea on how well this NUC would build FreeBSD. I don't expect this to be a build machine, but having spent a while shopping for build machines recently, settled on a Hetzner VM eventually, it is the only benchmark I really care about. Make with -J4 build worlds and build kernel took 2 minutes 45. That's hours, not minutes. 2 hours 45 minutes. This isn't the fastest in the world, but it is about an hour and 15 minutes faster than my X270 with its 2015 i3-6300U. Yeah, newer generation. It's faster. The difference, 5 years-ish make. Yeah. Okay, so graphics in the 10th generation Intel processor wasn't supported by DRM current KMod, and I had to install DRM devel KMod. With the devel KMod, the NUC is happy to push all the pixels off the 4K TV I have here and even drive additional second monitor connected with the USB-C HDMI adapter at the same time. Audio works through the front jack, and after changing a sysctl hwsnd.default_unit from HDMI 2, so that is not a problem. Manu helped a bit with, apparently there's an issue when the display is blanked and turned off. Audio will stop, but won't come back when the display does. So Manuel Vado, always helpful in embedded space, suggested setting another sysctl disable power well equals 0 in loader.conf. This resolved the problem for me. It's kind of interesting that display affects the audio.
Oh, well, it's audio over HDMI.
Oh, right. Yeah, then it's more connected than... Yeah. So sure, the Wi-Fi in the NUC is not supported yet. I stuck a cheap RTWN-based USB Wi-Fi dongle in the front port, and external USB Wi-Fi is cumbersome on a laptop, but on a machine that is rarely moved, it's fine. Yeah. The NUC has 5 USB ports, 3 USB-A and 2 USB-C. USB-C on the back has a little lightning bolt next to it, and I imagine that means it's the one with Thunderbolt support. Yeah, that seems to be the case. I did a disk speed test to a SanDisk Extreme portable SSD. The front port managed 200 megabytes per second or so, while the rear Thunderbolt one got to about 160 megabytes per second. Megabytes, for reads and writes. My MacBook Pro manages the advertised 500 megabytes per second read speed, so I need to dig into whether this is a hardware problem or a FreeBSD one. Luckily, I have two, so installing Linux to test performance won't be a bother. Okay, so all in all, storage, graphics, audio, Ethernet works or is supported. USB, suspend and resume, the SD card slot and Thunderbolt, not yet, but USB, suspend and resume and SD card slot works. Wireless, as mentioned, is not supported yet. And for Thunderbolt, he writes, I have no idea what the implications of this are. But yeah, I guess someone is.
Yeah, like you'd have to have Thunderbolt devices and know how they work. I do not.
Yeah, to actually make that determination. Yeah, okay, cool. Nice little device.
You know, your face is getting on the live stream via a NUC at the moment.
See, it's useful for many things. Okay, then next we have a nice article about PF table size check and changes.
Yes, so this is over on the Dragonfly Digest. Basically, I think Justin Sherrill over there was reading the mailing list and came across a bit of information he hadn't seen before. So did you know that there's a default size limit to PF's state table? It's how many states it can keep open, right? You know, how PF keeps the state for open connection so it can know when a packet is related to an already open connection and that's allowed versus someone trying to open a connection or whatever. And also for NAT, when you're doing the NAT translation, it has to know, all right, the packets I sent out on my public IP on this port need to go back to this machine on the internal network when the reply comes in. Because basically you're taking multiple machines and having them go out one IP address. So when they come back, you have to know what this is a reply to in order to send the reply back to the person who made the request. So the when you try to load a web page on your phone, the response from the web server goes to your phone and not to your laptop, which would be very confused to be getting a reply from a web server it didn't ask anything of. Anyway, the user was asking a bit about how to increase the size of the table because they were getting an error message saying that when they're trying to load a large table of addresses into PF, they're getting the error PFCTL cannot allocate memory. And he says, I know on FreeBSD, the default table size limit is far lower than that on OpenBSD, and it seems maybe that's the case in Dragonfly as well. Does anyone know how to raise the PF table size limit on Dragonfly? And that's where someone chimed in and said, in your PF rules, you can set limit table entries to a number. You can see the post here from Matt Dillon explaining that. However, the user then also commented about a sysctl on FreeBSD called net.pf.request_maxCount. This is related but different setting. So this setting controls when you're using pfctl to read a text file that maybe has a block list in it, and you want to load that into a table in PF to be able to, list of hosts that you're not allowing to connect to SSH or something. That requires that the kernel allocate enough memory and pass that for you to fill in with the list. And it's a bad idea to allow the user to request arbitrarily large amounts of memory from the kernel. So the sysctl allows root to control the maximum number of entries that can be passed to the PF IOCTLs in one go. So if you have the default is 65,000. If you need to load more than 65,000 rules or table entries in one, you have to do two separate IOCTLs, or you have to raise that sysctl to allow more memory. So it might be that Dragonfly is running into this where the limit in the kernel is a static limit and not exposed as an adjustable sysctl, and it might be that they want to switch to a sysctl like FreeBSD did so that root can control how large a list you can load in a single IOCTL rather than having to make multiple calls.
I see. Yeah, so nice to have this in Dragonfly.
Yeah, so in particular, Justin wasn't aware that there was a limit on the size of the state table inside PF, but I'm not sure that raising that limit will actually solve the problem the user was having, which is trying to load a very large list into that table. Even if there's enough room in the table in the kernel, you might not be able to send the entire list in as one go. You might need to feed it in smaller pieces.
All right. So it's time for the BSD bits this week. Bite-sized chunks around the web that we found about the BSDs that are necessarily interesting to more than one person reading those. So we mentioned it here on the show. The first is Tmux and Beehive over at callfortesting.org. So did you know that Tmux can provide console logging and command injection to Beehive virtual machines? So this is an article by Michael Dexter. And he writes, the bench testing of virtual machines for up.bsd.lv benefits from a workbench test harness that captures console output from the loader onward and enables command injection at every stage of the virtual machine's lifecycle. While OpenSSH is generally the go-to remote management tool of physical and virtual machines, it is of little use for a machine with failed or absent networking. Fortunately, the familiar Tmux terminal multiplexer provides exactly the desired functionality. So with the console management, you can do a thing like Tmux new, of course, and then run your Beehive in there. So it's used by several Beehive management tools to allow an operator to attach and detach from a virtual machine standard I/O console with a simple example provided. And now console logging with a similar example, this can be expanded to include a log file, in this case freebsd.image.log, but you can name it any way you like. And using the pipe-pane option feature in Tmux, you can put everything into a separate log file and read it while the machine is happily running in the background without having to attach to it to see what's logging on the console at the moment. Note that the exact target window and pane in the form of VM:0.0 is needed for logging to play nicely with other Tmux sessions. Tim Chase here pointed this out, and the greater than sign will override the log, while of course greater sign, as I always try to teach my students, and they override it anyway, greater sign will append to it, of course. Yeah, the logging is quite remarkable in that it works with cursor-based utilities and sometimes provides cleaner output than direct attachment. There's a bit more information about command injection using tmux send, but I leave that up to you to read. There's also a shell script that's nice and handy, who's doing all that to ease up your work a little bit using these utilities. Then next we have Azure and FreeBSD, so there is a bit of an update in the marketplace.
Yes, so this is the official FreeBSD 12.1 image available for spinning up in Azure. There was some issues of some kind at some point, and it was causing this to take, this was meant to be available when 12.1 was released months ago, but at least it is there now.
Yeah, so people can run FreeBSD on Azure with a more recent version. That's working.
Yes, well, the most recent version of FreeBSD until 12.2 comes out.
Mm. And we have found on YouTube a graph tutorial, not the goat.
No, this is something between latex and markdown, apparently.
Yeah, some hybrid of sorts.
Well, it's basically using man pages. It's the man page type formatting macros.
Yeah.
And typesetting.
So if people want to get into this kind of work or doing some man page editing, then a graph tutorial is a good start, and they go through the basic steps of writing a man page or editing one.
Well, I think they're using it as more of a general text formatting rather than man pages specifically, but
sure, man page is just a special incantation, I would say. You can write books in graph if you're so inclined. It's not the best tool around, but yeah, well, choose your own pain. Speaking of pain, have you done a backup today? Some people say, wow, no, I just do it when I have time. No, you shouldn't. You should do regular backups, and why not use a proper backup utilities just for that? For example, Tarsnap, which is the online backup for the truly paranoid people out there, a secure, efficient online backup service for you, because what it does, it takes your files, does a bit of segmentation, deduplication to keep it small enough, but then, important part, before it backs them up into the cloud, it encrypts them locally and gives you the key, well, it generates the key, of course, and encrypts it locally. And once that data that you want to backup is encrypted, it will store that in the AWS cloud in this case, and no one there can just grab your files because they are just gibberish and don't decrypt properly unless you have the key. And since you're the only person holding the keys to the castle, in this case your backup, you are the person, when the need for the restore arises, you can pull it down using the tarsnap client, apply your key that you generated and hopefully saved somewhere else safely, and then you can decrypt your backups. So this is the nice way that tarsnap provides for you.
Yeah. You never think about your backups until you need them. And that's not the time you want to discover that you don't have any or that they weren't working. So take this as a reminder to go test your backups and then realize they're not good enough and then go to tarsnap and make ones that are.
Yep. And if you need a bit of an explanation how that all works, there's a whole book about tarsnap called Tarsnap Mastery over at Michael W. Lucas's author page. In the nonfiction area, you will find the tarsnap book that explains everything, how to run tarsnap, how to install it, and generate keys and do the backups properly. It's all in there.
Good recipes for managing the backups, making it so you don't have to think about them.
Yeah, that's what you want to have. They want to run in the background, and in case you need them, you are lucky that you did do them 5 seconds ago and not 5 years ago. All right, time for the feedback and questions this week. We always get nice feedback and questions. Thanks for that. We collect them and try to go through them. It's a lot sometimes and sometimes a little less. But if you want your question answered, hopefully on this show, then send us an email to feedback@bsdnow.tv and it will be added to the queue. And hopefully in a future episode, we will have an answer for you. Sometimes we get questions that we can't answer. They're very specific or out of our league. But for most people, we could give at least a couple of hints. So the first this week is Chris with a ZFS question, which we like particularly well. But you can ask us pretty much anything about computers and BSD in particular. So Chris writes, first off, thank you for what you do. I've been with you all since the beginning and have enjoyed the edutainment. Oh, wow. Hey, thanks. That's nice. I've been like 2/3 of the way with it. And Alan has been from the very start. So, yeah.
Getting close to 7 years.
Mm-hmm. It's, yeah. Yeah, okay, so then I have a pool of 2 VDEVs with 8 times 8 terabyte drives, and I just purchased 8 times 10 terabyte drives to add a new VDEV. The current drives are a few years old, and I'm wondering if I should swap some of the new drives into the existing VDEVs. This would create a mix of old and new drives across all 3 VDEVs. Is it worth the trouble? What would this process look like? I realize this could be tedious, but might help if there are successive failures due to age or wear and tear later on.
Okay, so you can do that. As you mentioned at the end, you have an IX Systems 2 server with an external 45 bay disk shelf. So importantly, that means you have the spare slots, which allows you to connect all of these drives at once. So you have 24 drives in total now. So if you just connect the new drives, you can use the zpool replace command to replace, some of the drives in the old VDEV with the drives from the new VDEV, or from the, well, not the new VDEV, the new drives. So you can use the zpool replace command to swap, disks 1, 2, 3, and 4 with 4 new disks, and then also disks, 9, 10, 11, and 12 from the second VDEV with the other 8 new disks, or other 4 new disks. And then you'll have 8 unused disks left over, which you could then add as the third VDEV. And that would give you VDEV 1 would be 4 new drives and 4 old drives. VDEV 2 would be 4 new drives and 4 old drives. And then VDEV 3 would be 4 drives that used to be part of VDEV 1 and 4 drives that used to be part of VDEV 2, or some other mix of those. The main advantage of having enough disk slots or SATA ports to do this online means that there's no risk. You can do all of these replaces concurrently so that all the drives can be reading and writing at once. Meaning you won't have to, if it takes 2 days to do the scrub that's required for this, you would do it once and finish all 8 drives instead of doing one that takes a day, and then the next day you can do another one until it takes 8 days to do it. And importantly, unlike pulling out the old drive and putting in the new drive and doing an offline replace, you're not depending on the parity. You have all 8 drives in VDEV 1 online, and you're basically adding in a 9th drive to replace one of those, but the new and the old are online at the same time, so you don't need the parity. But if one drive does fail, you do still have the parity. Whereas, if it's a RAID Z 1 and you pull one of the drives out and put the replacement in, if another drive fails during that replacement, then you've faulted the pool. So being able to do it online is handy. So you could mix these new drives into your old VDEVs. There's a downside to that, obviously. Because your new drives are 10 terabytes, if you just add all 8 of those as a new VDEV, you will get more space. Because when you make a VDEV, you use the lowest common denominator size of the disks in that VDEV. But when you're adding this third new VDEV, it doesn't have to be the same size as the previous VDEVs. So you would be able to actually get, if it's a RAID Z2, 6 times 10 terabytes. So instead of 6 times 8 terabytes. So you're going to get this extra space. Whereas if you mix it in to one of the older VDEVs, then you're not going to get that extra space. Because as long as one of the drives in those VDEVs is still only 8 terabytes, then each drive is only treated as 8 terabytes. The one other option you have is to replace all of the drives in the first VDEV with the new drives, which would then allow that VDEV to grow from 8 terabytes per disk to 10 terabytes per disk, and then adding the new or the old 8 drives as the third VDEV. The only advantage to this would be that now VDEV 1 will have a bit more free space, and VDEV 3, when you add VDEV 3, it's going to be completely empty, right? So you're going to have your original VDEVs that are mostly full, and then this empty VDEV, and you're not going to get as even performance. Whereas if you do this other thing, VDEV 1 will have a couple terabytes of free space added to the end of it. But I don't imagine that's really worth the hassle. So in the end, I would probably just replace or just add all 8 drives as a new VDEV because you would get the extra space that way. And if you're worried about the other drives failing, then you might want to consider just adding some spares to the pool. And those spares can be these some more of these 10 terabyte drives. And, if you replace an 8 with a 10, it works fine.
But yeah, there's a path forward.
Yeah.
And
or, if you're that worried about it, then you're just going to need to replace the drives entirely. I don't know.
Yeah.
But yes, because like you say, he says he needs a meticulous plan because this is in a colo. So luckily, the only colo part you need to worry about is plug the 8 drives into new slots and don't touch the old drives. And then everything else is just zpool commands. You either zpool add a new VDEV of the 8 new drives, or do a bunch of zpool replacing to bounce things around. Either way, remember to do, especially with the zpool add, make sure you do the -n, which doesn't do it, but just prints what it'll look like to make sure you did it right. Because what you really don't want to do is add 8 single stripe VDEVs to the end of your pool when you actually meant to add a RAID Z2 of 8 drives.
Yeah, but I think you should be fine doing it just the way described. And yeah, so good luck with your server, and thanks for your feedback. Then next we have Patrick with a question about Tarsnap. See, we can basically let people speak about our sponsor. Goes like this. Hi, Benedict and Alan. I'm a longtime listener and BSD dabbler, thanks to you. And I'd like to say I am very much enjoying your show. I look forward to it every week. Hey, great. That's nice feedback. That's nice to hear. So in episode 355, apparently I mentioned that Tarsnap works in macOS, Linux, and Cygwin, because it does. I thought you might like to know that it also works on the Windows subsystem for Linux fine. I use it for monthly safety backups.
Yeah, I think the Windows subsystem for Linux uses Ubuntu packages. And so since it works under Ubuntu, it'll work on Windows under WSL as well. Cygwin just has the advantage of it even works on older versions of Windows that don't have WSL. Or machines where maybe the WSL is not installed. But yes, either of those two ways, you can get Tarsnap on Windows. And yeah, there's so basically not any mainstream OS that it doesn't work on. And even most of the not mainstream OSs it'll work on. Pretty sure you can compile Tarsnap to run on HPUX or IRIX or whatever else you need as well.
Yep, the secret sauce is not so secret. And if you like, you can write your own client or use the ones that are...
It's one of the advantages to the client being completely open source is that you can make it work on anything. Somebody should write an Android version of Tarsnap.
See, perfect summer project for people who don't know what to do because they can't go on holidays or something. And it's a nice little project that benefits a lot of people. So yeah, thank you, Patrick, for that addition. And yeah, good luck always Always may your backups restore safely in case you need them, but hopefully you never need them at all.
Thank you, Patrick.
Last but not least, the third person is Pin with a package source question. At least that's what people name themselves when they... A comment, yeah. Regarding where you can check packages in package source online. Ah, yes, that's, I think, from a previous episode, a comment. Ah, yes.
Or comment, I think. Yes, somebody was asking a question about package source, where we were talking about how they could use package source to get something like FreeBSD ports, but on other operating systems. I think it might have even been somebody was using AIX or HPUX or something and needed some modern stuff. And I know I'd seen a presentation about using package source to get modern Python on some like ancient Unix that not many people had to use anymore. But so yes, apparently the answer to the package source alternative to or equivalent to fresh ports is packagesource.se, pkgsrc.se. And yes, this seems to be exactly what we were looking for.
Search box and all the newest, updated, latest changes in there to whet your appetite for an update.
Yeah, package source really is amazing. It's, you know, a slightly smaller collection, but the fact that it works on NetBSD and Linux and OpenBSD and Illumos and a whole bunch of other operating systems makes it really, really useful.
Oh yeah, they have nice statistics as well. And you can dig into the categories on the left. So what's new in the math department, for example, and you can see all the packages there. Very cool. That's exactly what we were looking for. And that pretty much is the comment we got here. So see, it's not just feedback from us to you, but also from you to us. And that's the way it should go. It's not a one-way street. And that makes the show overall better because everyone who's listening can benefit from that. With that, we say thank you and keep listening to us. And you will hear from us next week. That sounds like a threat. But it isn't.